In today's lesson, we're going to take a look at section 8.5, solving equations containing radicals. The key to solving equations that do contain radicals is to isolate the radical on one side of the equation if you can. Before we actually start doing that, I want you to think about what we talked about earlier, what a radical is and how else it can be expressed. If I have the square root of 4, we talked about how this can actually be written as an exponent. The index being 2 and the exponent being 1. And then that can be written as 4 to the 1/2 power, where 1, again, is that exponent, and 2 comes from the index. So now let's think about this number expressed as a fraction. If I'm trying to get rid of this fraction right here, how can I make that a 1? If you think about your properties of exponents, I can get rid of that half by squaring it, because 1/2 times 2 is equal to 1. So now let's go back to the radical, the same sort of thing. How do I get rid of a square root? Well, you're going to square it. And the square root is going to cancel with that exponent. As long as the index and the exponents are the same, they cancel each other out, and you get whatever the radicand is, which happens to be 4. Another way to think about this is if I have the square root of 4 and I'm squaring it, that means I'm timesing it by itself. And we talked about this in a previous lesson. The radicals cancel out and you just get 4, or square root of 16, which is also 4. So let's take a look at the first one. We have square root of 5x plus 1 equals 4. Again, the first thing that we want to check for, we want to make sure that we isolate that first radical. And in this case it is, so it makes it easier. Then you want to kind of work your way towards the variable. The first thing you need to do is to get rid of the exponent. So I'm going to square the exponent. But if you do something on one side of the equation, you have to do it to the other. So the square root and the square cancel out, and you will be left with 5x plus 1, and that will equal 16. From there, you're going back way to the beginning of chapter 1 and just solving, or chapter 2 and solving the equation. You're going to subtract 1, and then finally divide by 5. And again, how you're going to check this is you're going to take your solution and basically just plug it back into the original problem to make sure it works. So you're going to do 5 times 3, our solution, plus 1. We're going to take the square root. That's going to give us 15 plus 1. Square root is 16. And you check to make sure it equals 4, which this does. In our next example, again, we're working with an equation that has a radical sign in it. And like I mentioned in the first example, the key is to make sure you isolate the square root or the radical. By isolating, everything that's underneath that radical can stay on that side. But you'll notice this plus 2 is outside the radical, so we need to move it to the other side. You're going to do that by subtracting 2. Once you do that, you're going to get 5x plus 3. That equals -2. The square root is now isolated. Since that's isolated, we can go ahead and try to get rid of the radical. Since the index is 2, you're going to square both sides. You're going to end up getting 5x plus 3 equals 4. And then you're going to go ahead and solve it. You're going to get 5x equals 1, and x equals 1/5 when you divide by 5. So again, what we're going to do is we're going to double check the answer. We're going to get 5 times 1/5 plus 3, and we're going to add to 2. That's going to give you 0. So 5 times 1/5 is going to give you 1 plus 3. We'll get the square root of 4 plus 2. That gives us 0. And you'll get 2 plus 2 equals 0, and 4 equals 0. Well, hopefully by this point you'll realize that 4 does not equal 0, so that doesn't work. So 1/5 is not the answer. Pause the video for a minute and see if you can figure out why. And kind of go to this step right here where you have the square root of 5x plus 3 equals -2. So why does this not work? Well, again, let's think about this part of this process. I have the square root of 5x plus 3, and that equals -2. Is there ever an answer where you take the square root of a number where it equals something negative? And hopefully you're answering no, because if we take the square root of 4, that gives us a +2. If I take the square root even of a -4, though, we talked about how this is no real solution. So we never end up with this negative number. So 1, you should always check your answers when you're going through these. And 2, if you do get something like this, where the answer, when you isolate the radical, gives you a negative number, you're going to write no solution. Let's look at example number 3 now. Again, we have a radical sign in the equation, but you'll notice that the radical part isn't isolated. So what we're going to do is we're going to bring this negative x over to the right side. We're going to end up getting 5 minus x equals x plus 1, or you could put 1 plus x, either way is fine. And you're going to get rid of that radical in the next step. To do so, you're going to square it. But when you go to square the other side, don't do it individually, but again, you're doing the entire side as one quantity. On the left, the square root and the square cancel out, and you get 5 minus x. And then look at the right side and notice kind of what you get here. X plus 1 squared. This is a binomial and you're squaring it. So hopefully you remember that since it's a binomial and we're squaring, we're writing it twice, and you need to FOIL. I'd kind of make a note there. Again, binomials, you got to FOIL. So we're going to do the first, outer, inner, last. Combine like terms. You get x squared plus 2x plus 1. From here, this is a regular equation, except you'll notice that now we have an exponent of 2, which makes it a quadratic. So this is a quadratic. And again, if you remember about quadratics, we need to set it equal to 0. So we're going to add x to both sides, and we're going to subtract 5. That's going to cancel this out. That will cancel this out. It will set the equation equal to 0, and you get x squared plus 3x minus 4. And since it's a quadratic, we're going to talk about going back to factoring. So coefficient is 1. I'm looking for two numbers that multiply to -4 but add to +3. That's going to be +4, -1. I'm going to set both of those to 0. X plus 4 equals 0. X minus 1 equals 0. X equals -4. X equals +1. Again, what you're going to do is you're going to plug both of those in to check it. And we're going to start with the original equation, which happens to be square root of 5 minus x minus x equals 1. So let's try that for the negative 4 first. Square root of 5 minus a negative 4. That's going to give you square root of 9. I'm going to minus a negative 4. So the double negatives become a positive 4. We're going to see if that equals 1. 3 plus 4 equals 1. Nope, that's an extraneous solution. We learned about that term in the previous section. So let's try 1. Square root of 5 minus 1 minus 1. Does it equal 1? Square root of 4 minus 1 equals 1. 2 minus 1 equals 1. So that works out. So our solution will be x equals 0.